Hello, everyone. Today, we are going to learn Task 3, Installation and Debugging of the Upper and Lower Die Plates. In the turret components of the THMDTK-1 Mechanical Equipment Assembly, Debugging and Control Technology Training Device, the upper and lower die plates play a decisive role. Their precision is directly related to whether the punching die can be accurately closed, and further affects the effectiveness of the stamping forming process. So it is very crucial to master the installation and debugging technology. Next, we will carry out the study through the task implementation process. In this task, it is required that you select appropriate tools and measuring tools, and carry out the installation and debugging of the upper and lower die plate components according to the standard process to ensure that the equipment meets the high precision matching standard. It specifically covers two aspects: preparation and installation and adjustment. For the preparation, all kinds of tools and measuring tools should be neatly arranged for easy access and management. In the installation and adjustment link, it is necessary to accurately select tools, measuring tools, and processes. When installing, ensure that the screws are firmly tightened, and select appropriate measuring tools to adjust the precision and control the coaxiality error of the upper and lower die plates within the range of less than or equal to 0.04 millimeters. Our task objectives include knowledge objectives and ability objectives. In terms of knowledge objectives, you should be able to read the assembly drawing of the lower die plate, master the assembly relationship of the components, be familiar with the disassembly and assembly process of the lower die plate components, understand the concept of circular runout and master the measurement method. The ability objective is that through learning, you can select the right tools according to the structure of the lower die plate, disassemble and assemble the components in a standardized and efficient manner, operate the dial indicator skillfully and in a standardized way, and precisely debug the circular runout. In the specific operation process, when rotating the upper die plate, do not touch the dial indicator base to prevent measurement data deviation caused by the movement of the dial indicator base. When roughly adjusting with a square, it should be placed in a standardized way, and each square should be spaced approximately 120 degrees to ensure the accuracy and consistency of the rough adjustment. It is necessary to have an in-depth understanding of the concept of coaxiality, and be clear about the coaxiality error standard of the upper and lower die plates, which is the basis for ensuring the installation and debugging precision. When carrying out debugging measurement, do not place the pointer of the dial indicator on uneven places, otherwise the dial indicator is likely to jump, resulting in distorted measurement data. The task of this lesson is to debug the coaxiality error of the upper and lower die plates and control it within the range of less than or equal to 0.04 millimeters. So, what is coaxiality? Coaxiality is an index used to reflect the degree of deviation between the geometric axis of a part and the reference axis. Generally, cylindrical surfaces with symmetrical distribution are used to represent the allowable error range. It is of great significance for measuring the manufacturing and assembly quality of parts, and directly affects the performance and operation stability of the equipment. There are mainly three methods for measuring coaxiality. The dial indicator method is simple to operate. When measuring, rotate the measured part for one circle and record the maximum difference value of each section to determine the deviation. The coordinate measuring instrument calculates the deviation value by obtaining the axis coordinate data, and has high precision, which is often used for the measurement of high-precision parts. The laser collimator is suitable for the high-precision measurement of long-axis parts, and the precision can reach the μm level. It uses the laser collimation characteristic to measure the axis deviation. Next, we enter the preparation and the selection of tools and measuring tools. Before the equipment debugging, prepare a training site that is reasonably laid out and fully equipped according to the requirements to meet the installation and debugging needs. Also, clarify the assembly precision requirements of the lower die plate. Precisely adjust the precision during the installation and debugging to ensure the assembly quality of the upper and lower die plates. Finally, select the appropriate tools and equipment according to the structure of the lower die plate components, and avoid damaging the equipment through the standardized use of various tools and measuring tools. The details are shown in the table. Next is the core part of this lesson, the task implementation link. The first step is to install the lower die plate and adjust the coaxiality. Align the holes on the die plate with the holes on the workbench surface. The second step is to roughly adjust the coaxiality. Adjust with 3 squares to make the centers of the upper and lower die plates as coaxial as possible. Then, initially fix the lower die plate with screws. Pay attention to the tightening degree of the screws during pre-tightening to facilitate subsequent adjustment. If the deviation between the upper and lower die plates is still large after the lower die plate is adjusted to the limit position, rotate the base of the lower die plate 180 degrees and reinstall and adjust it. The third step is to adjust the coaxiality between the lower die plate and the upper die plate. Firmly attach the dial indicator base to the upper die plate, make the indicator head fit the edge of the lower die plate, and control the depth of the indicator insertion within 2 to 3 millimeters. Slowly rotate the upper die plate, observe the value of the dial indicator, lightly tap the base of the lower die plate with a copper rod for fine adjustment. After reaching the error range, pre-tighten 4 screws diagonally. Continue to observe the parameters during the tightening process, and fully tighten the screws after there is no error. The fourth step is to tighten the screws. Complete the tightening of all screws in a diagonal order to ensure that the lower die plate is firmly installed and meets the operation requirements of the equipment. At this point in the lesson, let's think about two questions. Before using the dial indicator to debug the radial circular runout of the upper and lower die plates, can the rough adjustment step with the square be omitted? Can the ordinary dial indicator be replaced with a lever dial indicator when debugging the radial circular runout of the die plate? Thinking deeply about these questions will help you better understand the debugging principles and methods. In the task implementation of this lesson, when installing the lower die plate and adjusting the coaxiality, we adopt the two-level calibration method of rough adjustment with a square and fine adjustment with a dial indicator, and dynamically monitor the tightening parameters to strictly control the precision. This requires that in future study and work, you should be rigorous and meticulous, pay attention to details, and pursue ultimate precision. In the process of completing the task, different tools cooperate with each other. For example, use an Allen wrench for disassembly and assembly, use a dial indicator and a magnetic gauge stand to measure the precision, and use a square for auxiliary rough adjustment. You should learn to start from the overall system, integrate resources, break through the limitations of a single tool, cultivate the innovative thinking of system integration, and improve the ability to solve practical problems. Finally, let's conclude this lesson. We have systematically learned the whole process of using a variety of tools and measuring tools to complete the installation and debugging of the upper and lower die plates. The core technical points are the two-level coaxiality calibration method of rough adjustment with a square and fine adjustment with a dial indicator, as well as realizing the parameter monitoring during the dynamic tightening process to make the equipment reach the required precision for operation. After class, you need to complete the relevant exercises. I hope you will review after class, master the knowledge and skills learned today, and accumulate experience for future study and work. Today's lesson ends here. Thank you.